Hello, and welcome to this section on Xamarin.Forms. A lot of you have requested a section on Xamarin.Forms for a long time, and actually a lot of you have also requested a couple of things that we're going to be covering during this section. Some of which include using Windows. Some of you have found it a little bit difficult to follow the instructions from Mac to Windows, although they are quite similar. So if you're using Mac and you've already familiarized yourself using Visual Studio on your Mac, you will find that it's pretty much the same thing. And also we're going to cover how we can actually connect to a Mac from a Windows PC, from Visual Studio on Windows, to be able to test our Xamarin apps on an iOS device or an iOS simulator. So let's just go ahead and get started. I am right here on Visual Studio 2017. This is the latest version. Right now is the 15.3 that was released just a couple of days ago. But you can do the same thing with pretty much any version of Visual Studio 2017. So what we're going to do is go to the new project section and select create new project, or if you don't have the start page available, you can always go to file, new, and select project. On the new project window, you will want to find Visual C# as the language that we're going to be using, and you can select cross-platform. In here, you will have this cross-platform app Xamarin option, which is actually the same template that you have to pick whether or not you're going to be creating a Xamarin.Forms project. This is a little bit different on Mac. On Mac, you will actually see a list of different options. Make sure that you select the one that says Xamarin.Forms and that uses XAML as the UI technology, and make sure to follow up with this video. So once you have selected cross-platform Xamarin, what you have to do, of course, is set a name for your project. So let's go ahead and name this My Books. We're going to be creating an app that is going to be listing our own books, and click on OK. In here, this is the important window. This is where we're going to be setting up the entire template of our project. So the first thing is that we're going to select a blank app. We're going to start up from scratch. You could also select master detail. Master detail meaning that you have a master that has a list of many options and the detail that changes depending on the option that you selected on the master. But right now we're just going to start with a blank application. In the UI technology, make sure that you select Xamarin.Forms. You could also select native, so you can continue building native applications. For this section, let's just go ahead and select Forms. And then make sure that you select portable class library. We've covered the differences between shared projects and public class libraries before, so I'm not going to cover it deeply in this video. Just make sure that you select this because it's the one that I recommend you use, because I feel it's just better when it comes to sharing content or sharing your code that you already have with many different kinds of projects. Finally, click on OK, and the project is going to be created. If you have installed Windows 10 development tools on your computer, you may find this dialog pop up. You will have to choose a version that is going to be targeted for your Windows project. This will only appear if you have the available tools installed. If you are on the Mac, this is actually not possible because you cannot create Windows applications from Mac. Because we are actually just going to be focusing on the Android and the iOS projects, I am not going to be completed this session, so I am going to click on cancel. Then the iOS project is going to be created. You can see how right now I only have a portable and an Android project, and as soon as it's ready, I already have the 3 projects in here. Now that you have the project created, let's explore it a little bit. By default, you have this app.xaml.cs file open. Let's just close it. We're not going to be using it right now, and explore what the project is conformed by. So the first thing that we have is, of course, the solution, which is going to be holding the 3 projects that are necessary for us to build a Xamarin.Forms application for Android and iOS. The first project is the portable project. And in here we have the app class that we're going to use just a little bit, but we have the most important class right now, which is the main page. And this is exactly where we're going to be defining the entire UI for our application. Well, this and another page. But just keep in mind that mainPage.xaml is actually now the main page. The main page is now hosted inside of the portable project. With Xamarin.Forms, remember that now you have a shared code, of course, just like in any Xamarin app, but now you can actually share the UI. So we're going to be sharing the UI directly from the portable project. We still have the Android and the iOS projects, but on Xamarin.Forms, we actually barely need to touch these projects. Everything that we're going to be designing and coding is going to be happening from the portable project. We do need to do a couple of things inside these two projects, and as your application grows, you may need to do a thing or two inside of these projects. But remember that Xamarin.Forms will allow you to actually reuse the 100% of your code. From 95 to 100%, in our case, we will need to code about 3 to 5 lines of code on the Android and the iOS project. So as always on Android, you have the same structure that you will find in any Android project. This is actually still an Android project full with everything that an Android project has, including the main activity, and the iOS project the same thing, except that notice neither the iOS or the Android projects have a UI file. In the resources, you won't find the view in the form of an XML file like we do on Xamarin.Android, and on iOS you won't find the storyboard file like we do on Xamarin iOS. But you do find this main page.xaml that is exactly the file that we're going to be using to define the UI. And the file that we're going to be using to control the UI, well, it's right here. Inside of main page.xaml, if you expand this option, you will find the main page.xaml.cs. That is exactly the file that we're going to be using to control whatever is in main page.xaml. So how does this happen? Well, you will actually notice that main page is a partial class. And if you are already familiar with C#, you know that we can have partial classes, partial methods, that are actually defined in more than one file. So it turns out that this main page is actually defined in two files, two separate files. One being the main page.xaml.cs, which is a C# file, and one being the main page.xaml, that is a XAML file, that is actually going to allow us to define the UI for our application. So we have this main page.xaml file that we have said we're going to be using to define the UI. At least this file along with other XAML files that will allow us to define each and every single page that is going to be conforming our entire application. If we wanted to see how this looks, we can actually just look for another window that is available inside of Visual Studio. So navigate to View, navigate to Other Windows, and find this Xamarin.Forms Previewer window. This will open another window inside of Visual Studio that will allow you to see exactly what it is inside of your file. So it is open right here, and I can of course pin it somewhere inside of my IDE so we can actually start seeing what is inside of the files. So if I were to actually open the main page.xaml and have the Xamarin Previewer somewhere along here, I will be able to see what is inside of this XAML file that is opened. Of course, the first thing that we have to do is rebuild the project because this is just a brand new project that hasn't been built at all. So we have to do that first. To rebuild a project, you can actually click on the solution, the entire solution, right click on it and click on Rebuild Solution. This will rebuild all of the projects inside of the solution. You can always do this individually with one project or with each project, but since we want to rebuild all of them right now, I will just click on the solution. Now it's worth mentioning that right now I am not connected to a Mac computer, so the iOS project won't actually be able to be built because all of that building an iOS project occurs on a Mac computer, as well as the render of the iOS project. So that is exactly why we actually won't be able to see the iOS version of our app until we connect to a Mac computer, which we will cover eventually. So you can notice how two projects were successfully rebuilt, but one was skipped. And the one that was skipped was in fact the iOS project, because right now we're not connected to a Mac, so Visual Studio knows that it will just not be able to do so, so it just skipped it. But now that we have the project rebuilt, notice that automatically the designer is re-rendering the XAML file that we have right here selected. And after just a couple of seconds, supposedly, this view is going to load and we will be able to see a label that has "Welcome to Xamarin.Forms" written on it, and that is actually exactly centered vertically and horizontally because of what is set as its properties. So here it is, it's been rendered, and in fact we can see that little label in the middle of the screen that says "Welcome to Xamarin.Forms." And I could always start working into this and say that I don't want to say "Welcome to Xamarin.Forms," I would just want to say "Welcome to this course." There it goes. So let's write this again. "Welcome to this course." There it goes. So you can see how immediately I start changing the values of the properties inside of this XAML file. I can see that reflected into the previewer. If I were to, for example, delete these values for centering it vertically and horizontally, it now has its default location, which is the leftmost of the screen and the topmost of the screen, or at least the parent that this label is defined in. So we're going to learn a little bit more about XAML during this video, but we're going to be doing it in another file. So this main page is going to help us list the books that we are going to be having. But we're going to learn how to list in later lectures. During this one, we're going to learn how to define the UI so the user can add new books. And this will be actually a new XAML file. So with the My Books portable project selected on the Solution Explorer, I'm going to right-click on it, select Add, select New Item, and in the window that is going to pop up, I will need to find a page, a XAML page, that will allow me to actually create new content. So that is actually called Content Page. But notice that there are two content pages. One, it just says Content Page, and the other one says Content Page and in parentheses C#. You have to make sure that you select the first one, the one that doesn't say C#. The difference is that if you do not select this one and select the C# one instead, you will have to build the UI with C#. So you will actually have to create each object and then add it to a container and everything. I just find it more simple to do with a XAML file. So make sure you select the Content Page option. You will actually see in the name section that you have a XAML file that is going to be created, and the name of the page is going to be New Book Page. So it's a good practice to name your pages with the page word at the end of the name, so you can actually see that we have the main page, and now we will have the New Book Page. So let's go ahead and click on Add, and this file is now going to be added to our portable project, and you will see how the structure of this file is the same one as the main page. We have a new book page.xaml file, and if we expand it, we have the new book page.xaml.cs file, because this again is a partial class that is defined in these two files. So let's go ahead and move this Xamarin.Forms previewer here. We will probably need to rebuild this project again to be able to see what is inside of this new file. And once we have rebuilt the project, we will be able to see again what is written inside of this XAML file. So it is exactly this file that we're going to be using to define the UI for our new book page. So by default, we already have this label that we are not going to be using, so I can delete it. And we have this stack layout that will allow us to add new elements inside of it. And as we add them, they are going to be stacked up. That's the name. And this stack layout is inside of the content page. So the content page will actually be using the entire available screen. And inside of the content page, we have the content of the content page where the stack layout is being drawn. Now it turns out that this section of content page.content is actually not entirely necessary, because by default the property that is being set is actually the content, so it's kind of like redundant to write it. So we can actually have just content page and define a stack layout inside of it. And it's inside of this stack layout where we can start defining the elements that are going to be defining the UI of our new book page. Let me start by adding some margin. I want everything inside of the stack layout to have some spacing to the left, to the right, and to the top of the screen, so I can actually set the margin directly from here. And the margin is going to be conformed by 4 int values. So the first value is going to define the spacing to the left. So let's make it, we can make it 10 or something. And to start defining the rest of the values, we actually can just use the comma. So we can use a value for the left margin, comma, then the value for the top margin, comma, then the value for the right margin, comma, and the last value is going to be the margin for the bottom. So we have this 10 right here. If I leave it like this, the margin is actually going to be applied to all of the sides. But if I want to, for example, do 10, now it will go 10 for the left and the right, and 10, the second 10 will mean the top and the bottom. Or I can actually just go ahead and do this, which will make a 10 margin to the left, which is the first value, 10 margin to the top, which is the second value, 10 of margin to the right, and 0 of margin to the bottom. So there are just these 3 different versions of setting the margin of a value, of an element inside of the layout. And right now we can actually just start writing whatever element we're going to be defining inside of this stack layout. So we could start by adding an entry. Entry is actually the name of the tool or the element that will allow the user to write something down. So you can see that as soon as I start typing, Visual Studio will try to autocomplete what I'm writing. So you can see that entry is selected. I can just type enter and I can close this definition like so. And notice how automatically there is now an entry inside of the designer. And just like this, I can define below this one a second entry. One is probably going to be defining the name of the book. The second is going to be defining the author of the book. And finally, I am going to need a button to save the changes. So a button that says save, so the user can actually save this book. So you can see how I defined the button just by writing down button, and Visual Studio auto-completed it. I just had to type enter. But there is something missing in here. The entries are kind of ready. They are working just by their own. They are already letting the user write something down, but the button, it's like blank. It doesn't say anything. We can actually set one of its properties that is called text to be save. And notice how immediately now the button says save, and now the user will actually know what will happen when they click on that button. This is basically how you can define a UI inside of XAML, and actually this UI, remember, is going to be re-rendered for iOS, for Android, and for Windows if that was the case. We will take a look at how this looks on iOS once we learn how to connect to a Mac computer. Right now we know this is working because it's being rendered correctly on Android, and just be certain that if it works on Android, it will work on iOS. It will just look a little bit different because it will use the native values or the native UI for iOS, but it will be working as well. We have created this new page that will allow the user to enter the name of the book, the order of the book, and click a save button. But right now there is something missing with the UI. The entries don't really let the user know what they are supposed to do with them. So we can actually just start adding a new value that is called placeholder, and it will allow the user to know what this entry is all about. So we can write this like write the name of the book. And notice how it adds as a placeholder. It's not text inside of the entry. If the user were to type or select the entry, this placeholder will be erased, but it now lets the user know what to do with this entry. And let's do the same thing for this other entry, write the author of the book. And so the UI is a little bit more ready. But this is not entirely working yet because we need to make sure that we know as the developer when this button is clicked so we can actually save whatever the user wrote down. So let me just actually close the designer because we won't need it right now. And we're going to be needing an event or to be able to know when an event is triggered. So that is exactly how this is going to work. Just like in Xamarin, we will have to know when a button is pressed by responding to an event. To be able to respond to an event, we will need an event handler. So whenever an event is triggered, that handler will be executed. So inside of Xamarin.Forms, we actually have the clicked event that is going to be triggered every time the button is clicked. So here, Visual Studio auto-completes whatever we need in this case, which is to create a new event handler. So we can actually just type enter and a new event handler is created. Notice that a name has been set, default generic name because we don't have a name of a button. But also, if we were to see right here inside of Visual Studio, the new book page.xaml.cs file has been opened. And that is because a new method has been added. That is exactly the same name of the event handler that has been set on the XAML page. So it's inside of this new method that we will be able to write down whatever we need to do when the button is clicked. Right now, I will just set a tiny alert to let the user know that the button has been clicked. But eventually, we will have to get the values inside of the entries and be able to save those values in SQLite. So in later videos, we will actually take a look at how to use SQLite to save everything on a local database. To be able to display an alert on Xamarin.Forms, all we have to do is call the display alert method. That will require 3 values or 4 in case you use the second version of the method. We will just use the first one that requires first a title, then a message, and then a cancel button. So let's just say that the title is going to be success. And the message is going to be we have handled the click event. And let's add a cancel value to the cancel button of the alert. That is just going to be great. And semicolon. And that's it. We will actually be able to see that we are able to handle the click event if this display is shown whenever the button is pressed. So before we go ahead and check out how this works, well, we actually have to navigate to this page because by default, it is the main page, the one that is being shown at the beginning of the application. So if we are not navigating to this new book page, we won't even be able to see it. And if we can't see it, well, we can't click the button, that's obvious. So during this video, we're going to learn how we can actually navigate from one page to another. So we can actually navigate from the main page that is eventually going to be listing the books to the new book page that will allow the user to, well, add new books. The first thing that we're going to do is explore a little bit the app.xaml.cs file. So you have this app class that is defined pretty much the same as a XAML page that we've been using, but this is not exactly a page. This is just a XAML file that we will cover just slightly in coming lectures. But we also have this C# file inside of it. This is actually a very important file because it's the first file to be executed when the app runs. So we can actually see that the main page of the application is being set to the main page that we have by default. What we could do is just change this instead of being main page to be new book page and we could actually see the new book page as the first page to be shown, but that is not what we want. What we want is to see a main page that has an add button or something like that, so that when we click that add button, we get navigated to the new book page. So let's change this definition. Instead of setting main page to a main page, we will need to set it to a new navigation page. This navigation page will actually allow everything to navigate from one page to another. This will work similar to what iOS does. If you have seen the videos on Xamarin iOS, you know that the navigation is performed through a navigation controller. The navigation controller then is kind of like hosting the entire navigation of the other controllers, the other view controllers, so you can navigate from one to another. So it's going to be working very similar to that. Now, the navigation page, of course, right now has no content. How do we set the main page as the content of this navigation page? Well, it's as simple as using one of the navigation page constructors that takes a page as the root page for the navigation. So notice how the second override of the constructor requires a page that is going to be set as the root. And we can do simply new main page, just like we had before, but now it is inside a navigation page. So the main page will still be the first page to be shown, but it is now going to be inside a navigation page, so we can actually navigate from main page to new book page. But the navigation doesn't happen automatically. We have to add a navigate button or a new button to the main page that will actually perform the navigation to the new book page. In this content page, in this main page, we could define a button just like we did on the new book page, but that is not the best thing to do. If you see any app, the add button is usually on the top right corner as an icon, or on Android maybe it's a floating action button. We're not going to cover floating action buttons during this section, but we will want to create this add button on a more convenient place than just in the screen. Like, we are going to be actually creating a new title section or title bar at the top of the screen that will actually be the one hosting this button. To do that, we can actually access the content page, which happens to have a property called ToolbarItems that will allow us to add items to a toolbar or a title bar. So this toolbar is actually going to be at the top of the screen and will allow us to add things like titles and buttons to the right and to the left. So right in here, we can define a toolbar item right away, like this. And this toolbar item will allow the user to navigate to the new book page. So maybe we can set its text. Right now, we're not going to be using icons. So we can actually do this quicker by setting the text to an add character. And we will actually also need to set the activated event handler. So just like with the clicked event handler for a normal button, on the toolbar item we have an activated event. And if we create an event handler for this, we will be able to know when the toolbar item is pressed or activated, so we perform the navigation. So now that we have this, we can actually navigate to this main page.xaml.cs and check out this method that we have in here that is going to be the event handler. And in here, we can actually just write navigation.pushAsync. And this pushAsync method is the one that is going to perform the navigation. So notice that what it is asking for is a page to which the navigation is going to be performed to. So in here, we can actually just set a new book page like this, and the navigation will be performed as soon as the toolbar item is activated or clicked. So we have added a navigation to our application. We had to change the main page to be a navigation page, And we added a new toolbar item to the main page that actually has an add button or a new button that will perform the navigation. It's time for us to test the application so that I can actually just close every single file, because all we need to make sure of is that in Visual Studio we have the Android application selected, or the Android project from this drop down, and select one of the emulators that you will have listed in here. So by default, Visual Studio probably added 4 emulators. 2 of them ARM emulators and 2 of them x86 emulators. So you can select either of the x86 emulators, which are way faster. I'm going to select the phone one and just click on Run. Visual Studio will now launch an Android emulator to which your app is going to be launched to. If you selected one of the x86 emulators, it will actually take very little time to launch, and you will see the application up and running like I have in here. And you will see this toolbar, or this title bar that was added, that we added to the main page, and that is available because we have a navigation page, and you have this add icon, or this is just a character. That is why it is shown very small. But it does work. If you click on it, the navigation will be performed, and you can see how we can actually start typing inside of this entry element and inside of this one as well. And if we click on save, we can see the pop-up or the alert that we added. So it has success, we have handled the click event, great. That is exactly what we said. And in fact, notice that because we have a navigation page, we can actually see this back button that we didn't even have to add. It was added automatically. Of course, in Android, you can always type the back button at the bottom of your Android phone. But on iOS, this is very important because iOS doesn't have back buttons. That is actually added by the navigation page automatically. You have already run your application on an Android emulator. And if you're on a Mac computer, running on an iOS emulator will be just as easy. All you will have to do is select the iOS project from the drop-down, and you will see a list of all of the iOS emulators that you have available on your computer. It will depend on the version of Xcode that you have installed, but it is very likely that you already had that installed and you are ready to go and test your iOS application on an iOS emulator. On Windows though, you will have to complete a step previous to be able to run your iOS application. You will actually have to navigate to the Tools menu, click on Options, and all the way to the bottom, or the second to last option, will be Xamarin. And if you expand Xamarin option, you will see the iOS settings. In here, you will have to have a Mac available on the same network so you can connect to it. So Visual Studio uses that Mac to perform all of the debugging and compiling and designing of the app. So all you have to do is have that Mac available in the same network, already on and already with Xcode and with Xamarin installed, and click on the Find a Xamarin Mac Agent button. You can just ignore this pop-up and you will see a list of the Macs that are available inside of your network. You can select the one that you want to connect to, click on Connect or double click on it, and if the Mac computer is available, the connection will be performed. By the way, you have to make sure that you have the exact same version of Xamarin installed on both computers. For example, right now I have just updated my Windows PC to the latest version of Xamarin, so it is not compatible because right here in Windows I have the version 10.12 of Xamarin iOS, while on my Mac computer I still have the 10.10 version. So I will have to go to my Mac computer, update Xamarin, and come back here to try again. Once I have updated my Mac, so it has the exact same version of Xamarin iOS than my Windows, I can come back here and double click or click to connect to my Mac. In this case, it's a Mac Mini that I have right here next to my Windows PC. And as soon as the connection is successful, I should be able to see in here that the Mac is connected. So the legend of no Mac connected will change to the name of the Mac, and you will see that this Mac icon is now colored. And now I will actually be able to run my application on an iOS device. And actually, if I were to open, let's say, the new book page that we have created previously, and were to go to view other Windows Xamarin.Forms previewer, I will actually be able to select iOS, and it will connect to the Mac and will actually render the iOS version of this UI. Once the render has been performed, you can see how indeed it looks very different, because this is how this will actually look on iOS. You can see that the entries look different than on Android, and the button does look different as well, but these are the exact same values. We didn't have to define twice the UI. We only defined it once with XAML on Xamarin.Forms, and it is being rendered specifically for each one of the platforms that we're going to be supporting, and it looks native. And in fact, now we can actually see a list of devices or emulators that are coming directly from my Mac, thanks to the version of Xcode that I have installed, so I can actually test this application out. Let's say that I select the iPhone 6. Now by default, this will actually run on the Mac computer. But if I go to Tools again and I go to Options and I navigate all the way down to iOS settings, right now I have this option to remote the simulator to Windows, meaning that the simulator will still be running on Mac, but the simulator will be rendered on Windows. So everything will still happen on Mac, but it's a window that opens directly on my Windows computer. So I will be able to see this emulator start right on my Windows PC. Now, in the resources of this lecture, there is actually a link to that tool that allows you to remote the simulator to Windows, but that is only available for Visual Studio Enterprise. But don't worry, if you don't have the Enterprise version, you can always click on Run, and the simulator will launch on your Mac computer. In this case, and to make things easier for you to see, I will run it directly on Windows, but just make sure that if you have a Mac computer, you are looking at the Mac monitor instead of expecting it to launch in here, in case you don't have that tool installed or you just don't have Visual Studio Enterprise. This is how the emulator will launch on Windows. It looks different than on Mac, but it is the exact same emulator. I mean, you have this section of the emulator that allows you to lock, take a photo, rotate, etc. That is easier to reach than on Mac, actually. And if your computer supports multi-touch, you will finally have an iOS emulator that supports multi-touch, because there's no Mac with a touch screen. But anyway, once the emulator launches, we will be able to see the app up and running. Once the emulator is ready and the app launches, you will be able to see that we also have this title bar. We also have this add character, and you can see that it is actually using what iOS uses by default, which is a blue color. And if we click on it, we are navigated as well. We also have this back button that is more important on iOS than on Android, because we do not have a back button on iOS. But we also have these entries that will allow the user to write some text down. And we have the save button that as soon as we press it, we see an alert, just like we do on Android, of course, with a different UI, but we have the same title, the same message, and the same cancel button. So there you have it. We have created an iOS and Android version with shared code, with shared UI, very easy. And we have also learned how to test this out on an iOS emulator, having a Mac connected to the same network as our Windows PC. So we have tested this Xamarin.Forms app on an iOS and on an Android simulator. And now that we have the Add New Book page ready, it's time for us to actually add new books to some place so we can actually start listing them. And what we're going to do is save them into a local database. And the local database that we're going to be using is SQLite. SQLite will allow us to have a light local database inside of the device that we can use to save virtually anything. So the first thing that we have to do is prepare our solution or our projects to be able to use SQLite. And to do so, it's actually quite simple. You may be familiar with adding NuGet packages to your projects, but we have actually done this step by step, project by project. If we want the same NuGet package in every single one of the projects, all we have to do is right-click on the solution, click Manage NuGet Packages for Solution, and this will actually manage the packages for the entire list of projects inside of the solution. So we can actually browse for SQLite-net-PCL and find the one that has this little beautiful icon, and that is by some Frank Kruger. Thank you, Frank. And select each and every one of the projects in the list and click on Install. You will, of course, have to accept some license terms and some permissions and everything, but once you have granted all of those permissions, your project will be ready to start using SQLite. You can make sure that this is installed by navigating to each and every one of the projects and navigating to the references section and see that in fact some SQLite NuGet packages or references have been added. On both the iOS and Android projects, you have some SQLite stuff, and actually the portable will actually have some SQLite stuff as well. This means that your projects are ready to start using SQLite. So let's go ahead and start using SQLite. The first thing that we have to do is navigate to the app.xaml.cs file. Remember that in here we have this main page that we are now assigning to a navigation page. This is because it is exactly the app class that is the one that is going to be launched at the beginning, and that will always be available. There will always be an instance of the app class available through the execution of the application. So this is ideal to store variables that should be available throughout the entire execution. And it turns out that that is exactly what we need when it comes to SQLite. We need a variable that will always be available that is actually holding the path to the database. So the path to the database, I'm actually going to be defining it right here before the constructor. It's going to have to be public, of course, because we want to access it from the main page and from the new book page classes. It's going to have to be static, so we don't have to create new instances of the app because we actually only want one instance of the app class. And it's going to be a string that is going to have the db_path, meaning the database path. And at the beginning, this is just going to be empty string. So how do we get the actual database path? Now, this is one of the things that we will need to code a couple of lines for each of the projects, meaning some lines for iOS, some lines for Android. This is because on Android, there is a path to some place inside of the device where we can store the file that is going to be holding the database. But this path is actually going to be different from the one on iOS. And we'll explain a little bit more about that in just a second. But we will actually have to find out how to get some values depending on the iOS or the Android project. So one of the ways that we can do this is to create a new constructor. And we can create this new constructor with a CTOR snippet and just type tab twice. And we have this new constructor, but this new constructor should also request the db_path. So we will be actually changing the constructor to request that database path. So we can actually let me just copy this because it has to still do the same thing that the previous constructor does, but it will also have to store in the db path whatever is received through the db path, which is the argument of this method. So why do we do this? Because on iOS and on Android, we are going to have different paths to the database, different file locations. And we're going to talk about it right now. Like if you navigate to the Android project and you open the main activity, you see how an instance of the app class is already being created when the application is loaded. All we have to do is use the other constructor, the one that is requesting the database path. So to create this database path, we have to use a platform-specific path. This path is going to be different for Android and for iOS. This is why we're not creating this path from the shareable code, but we have to create this path for each of the platforms. So this is actually going to be quite easy. The first thing that we need is a string that is going to have the file name. This is going to be the name of the file that is going to hold the entire database eventually. This does not have the path yet. This only has the file name. So the file name can be something like books_db.Siglight. And now we have a name for the file that is going to hold the entire database. The next thing that we need is the file location or the folder location, the folder where we're going to store this file. And for this, we're going to need to use the environment class. But notice that the environment class is actually inside of two namespaces. The one that we have by default is inside of the Android.os namespace. That is not the one that we want. The one that we want is inside of system, the system namespace. So we may need to write system first. So system.environment is the class that we need. And this environment class is going to have a method called getFolderPath, which will actually get the path of a folder. And the folder that we want is again inside of environment, but we have to use system to make sure that we use the correct environment class. And inside of environment, there is a special folder class. And the special folder has a list of a lot of folders that we may use. And the folder that we want to use right now is the personal folder. So this personal folder now will assign its entire path to the file location. So now we have the path and the file name. All there is left to do is define a final string that is going to be file path, actually full path, that is going to be equal to path.combine. So this method, let me just make sure that I can use the path class. If you are not able to find the path class, all you have to do is Control dot to see this little list of things that Visual Studio can do to solve this, and select using system.io. So that's the namespace for the path class. And path has a method called combine that will be able to combine two strings into one folder path. The first thing that we have to do is, of course, pass the file location, then the file name, and now the full path variable will have the full path of the database. And so we can change the constructor that we're using to the second one that we have just added and pass the full path value. So the portable project now has the Android database when the Android application is launched. This same thing we have to do on iOS, but with a different path. So let's navigate to the iOS project, and in this case, we have to open the AppDelegate. And notice that in here, we also have an instance of the app class. In here, we'll also have to use the new version of the constructor of the app class that we have just defined. We will actually be able to copy the code that we have here on Android and paste it on the AppDelegate and just make a tiny little change. Instead of using the personal folder, we have to use the library folder. But that library folder, as you can see, is not accessible directly through special folder. So what we have to do is find it a different way. Thankfully, the library folder is at the same level as the personal folder. So all we have to do is go back one level or one layer from the personal folder and then navigate to the library folder. So how do we do that? Well, we will actually be able to do that by using the path.combine method as well. So first we have to solve this issue with the path not being recognized. Remember that you can solve this by typing Ctrl dot on your screen so you can see this list of ways to solve this. Select using system.io, and we will have to use these on the file location as well. So path.combine, and we will have to combine some new elements. The first thing that we have to combine is two dots. If you are familiar with this will actually navigate back one folder. So if we are in the personal folder, after combining this with these two dots, we will be on the parent of the personal folder, which I'm not sure what the name is, but just picture this as we are now on the parent of the personal folder. We have gotten outside of the personal folder into its parent. And now all we have to do is enter one of the folders that is inside of this folder, which is the parent of the personal. So this is exactly where we have to write library. Now we will actually be inside of the library folder, which is kind of like a brother to the personal folder. They're in the same level. And this is exactly the path that we have to use. And so to the app constructor, we have to pass full path. So we use the second version of the constructor that we created, and now we are good to go. All there is left to do is head back to our portable project, open the app.xaml.cs, and make sure that indeed we are assigning the database path that we are selecting through the arguments of the app constructor to the local database path variable that we have defined as a public static string. So we have our iOS and Android projects sending to the shared project or to the portable class library a different database path for each of the platforms through a new app constructor that we have created. This means that now our project is completely ready to start using Siglight. So how do we start using Siglight? The first thing that we have to do is add new books, right? So we have to create new books directly from the new book page, add it to a Siglight as a book, but notice what is missing here. We don't really know what a book is yet. And of course, Siglight should know what a book is because it knows to know what a book is to be able to insert them and read them from a database. So let's go ahead and right click on the project, that is the portable project, select add and select class. We are going to be defining the book class, which is going to be defining exactly what a book is. This class, let's just make it public right from the beginning, and we'll have three properties. The first property is very straightforward, which is a string for the name of the book. The second property is also very straightforward, and remember that you can create properties by just writing prop, that's prop, and typing tab twice. So the second property, so it's also going to be a string, and this is going to be the author of the book. But we need another property, and this is actually going to be very important because we need to have this property whenever we want to insert something into Siglight. Each class that we want to insert into Siglight has to have a primary key. That is an identifier that will, of course, identify each of the elements inside of the table so we can identify them as different. So we can start by creating a new property. This is going to be an integer property and it's going to be ID. And this is going to be working as the primary key. But of course, Siglight will not know which to use as primary key. We have to specify that. To specify that, we can just write down primary key like this. And primary key is a type that we can use through Siglight, so make sure that if you are not able to use it or you have this error, you can always control dot to see this list and add a using statement to the SQLite namespace. And so primary key is now recognized and the ID is set as the primary key for the book class. Also, another thing that we have to do is make sure that this is auto-incrementing every time that we insert a new book. So if we insert a new book, the ID should increment. So for example, the first time that we insert a book, it may have an ID of 0, but the next time it should have an ID of 1. It can't have the same ID because it would mean that the same book is trying to be inserted, and since it already exists, well, there would be an error in there. Once we have the type of the element that are going to be inserting into the SQLite database, we can navigate to new book page and delete this display alert, or actually just comment it because we're going to be using it later. But before displaying any kind of alert, we have to insert the book into the database. Of course, to be able to insert the book, we need the book. So let's go ahead and create a new object of type book that is going to be book, and that I'm going to be defining as a new book. And right at the beginning, this book will have a value in 2 of its properties. Of course, we can't set the ID. The ID will actually be set automatically when we insert into SQLite thanks to the auto increment property. But we have to set the name of the book. And we're going to get this name from whatever the user wrote down in this entry. But guess what? We have no way of getting the value of this entry yet because it has no name. A variable that has no name, well, it can't be accessed. And that is exactly what we have in here. We have an anonymous object that we cannot use. I mean, it's right there and it works and the user can type on it, but from C# we cannot get its values. So let's go ahead and add a name. We have to do x:\name to be able to set the name of this element. And we're going to set this to be name entry. So this way we know that this is an entry by the entry statement in here, and that this is an entry for the name. I have mentioned a couple of times that it is important to have a naming convention, and I'm using this one right here. And I'm also going to be doing this for the second entry, and this is going to be author entry. And so now we have named both of our entries. We can now head back to where we were and set the name to whatever is in the name entry.text. And the same thing for the author, which is going to be equal to whatever is written inside of the author entry.text. And so we now have our book. The next thing that we have to do is insert this new book that we have into the database. And that is fairly easy. The first thing that we need is a connection. So actually SQLite, you can see how I have the namespace right here, has a class called SQLite connection. And I can create a new connection like this and assign it to a new instance of SQLite connection. Now, SQLite connection will actually require the database path. And the database path, we already have it. We can access it directly from the app. Remember that the app has that database path that we have set. And so the connection will now be performed with this file. So now this file is going to be used as the SQLite database. Once we have this, all we have to do is make sure that the table exists, because if the table doesn't exist, well, we cannot insert into it. So we can find the create table method, the one that is generic. So we have to establish the type of the table that is going to be created. In this case, it's going to be the book table. And so once this table is created, we can now make sure that we can insert into it. And to insert, all we have to do is call the insert method from the connection and pass the value that is going to be inserted. Now, there is one thing that I want to point out in here. There can only be one connection at a time. So if we don't close this connection to the SQLite database, we won't be able to open it again and we will get exceptions. So how do we close it? Well, there are two ways. We can go to connection or get the con variable that we have in here and call the dispose method. This will get rid of the connection variable, so the connection is opened again. We can use dispose because SQLite connection is implementing the iDisposable interface. So this dispose method will actually get rid of the instance that we have created, so the SQLite connection is free again. But there is a better way, because what happens if you forget to dispose the variable? That is very often. You forget to dispose a variable and then you get exceptions all over the place because you're trying to connect to a SQLite again and you are not able to do so. A better practice is to use a using statement, not to confuse with the using statement to a namespace, but a using of a variable. So the using statement works like this. I am going to remove the semicolon and I'm going to add some brackets. So everything that is inside, I think I am missing a bracket in here. Actually, I have one extra parenthesis in here. So there you go. So everything that is inside of these brackets will be the context of this variable. And this variable will only exist in this context. And actually, automatically, without us having to do so, the dispose will be executed. We can get rid of it. At the end of this block, this variable will be disposed. So this is a better practice because we don't need to remember to dispose the variable because the using statement is doing it for us. Finally, insert is a method that returns the number of rows that were affected or added, in this case, into the database. So let's get number of rows equal to con.insert and evaluate if number of rows is greater than 0. If it is, it means that the insert was successful. So let's go ahead and display an alert. I will just cut this from here and I will get rid of these comments and paste it in here and change the message because this makes no sense. Let's make this message book successfully inserted. Great. And let's add an else clause. If it wasn't inserted, meaning the number of rows is equal or less than 0, it probably won't be less than 0, but let's just say if it's not greater than 0, it means that there was a failure. Let's display that. Book failed to be inserted. And instead of gray, dang it. So there we have it. We are now inserting into the database. And we can actually go ahead and test this out. I'm going to test this out on Android. You have already learned how it works exactly the same on iOS. And we will see what alert we are getting. If we get the success alert, it means that we have successfully inserted into a new table of the database. Which, by the way, we are creating a table every time the button is clicked. But don't worry, because a new table won't be created. A new table will only be created if it didn't exist before. If it already exists, this execution will be ignored and it will just insert the new element. So very quickly, we have the app up and running in this simulator. We can navigate to add a new book and we can write the Lean Startup, which I recommend you read, by the way, by Eric Rice. And I'm going to save this and I get this very beautiful alert that says success. Book successfully inserted. Great. But guess what? If I click on great and I navigate back, I don't see any books at all because I'm not reading them yet. So in the next lecture, let's figure out how to read them so we can actually display the books that we have added into the database. We're now saving books into a local database with SQLite from our new books page class. it's time to navigate to the main page class and actually display those books into a list. So how do we do that? Well, we can actually go ahead and define a list view inside of the content page of the main page that will be displaying all of the elements. So that's the first thing that we're going to be doing. We have to define a list view like this. We can't define it like we did the buttons or the entries or the toolbar item because we have to set something inside of the list view. The list view is not just going to have like one element or one property. We have to define how every single cell inside of it is going to look. By the way, the first thing that we need is also a name because we want to access this list view from the C# file. So let's name this books list view like this. And so now it's ready to be used from the main page.xaml.cs file. But it is not ready yet to start displaying elements. And the way that we're going to be displaying elements is by using something called DataBinding. This will allow you to bind two objects, one from C#, one from XAML, in a very straight way. And this will be a little bit more clear once we have gone through this example. The first thing that we have to do with this list view is define the template for each and every one of the cells. So we can actually do that by accessing the item template property that we have inside of the list view. And the item template will actually allow us to define how these cells in the list view are going to be displayed. Now, to be able to use data binding, we will need to use a data template as the template of the list view. This data template will get the data from each of the elements of a list that is going to be the source of this list view and get the properties necessary to create a good cell. And inside the data template, we can define anything that we can imagine to start creating the cell. So the one that we can use very quickly is the text cell. So you may not find it directly by typing it like other elements, but make sure that you just write it like this, text cell, and you will be able to use it. Text cell is a template that is already available that will allow you to have a title and even a subtitle inside of a cell. But if you want to create more complex cells, you can use something that is called view cell. But right now, let's just stick with the text cell. The text cell will have a text, and it's in here where the data binding begins. We're going to do the binding like this with brackets. And in here we have the option to bind. There is the binding option. And what we have to do here is bind to a property of the book class. That is because a list of books is the one that is going to be the source for the list view. And for each one of the elements or the books inside of that list, we want to get their properties. So if we want the text of the text cell to display the name of the book, we will bind to that property. Binding name, which will bind the value of the text for this text cell to the value of the name property for the current book that is going to be drawn. We can also set the detail, which is going to be kind of like a subtitle, and we can bind this again with binding to the author. And now we have a text cell that is going to be bound to a book. Its text property is going to be bound to the name of the book. The detail property is going to be bound to the author of the book. All we have to do is bind a list of books to this list view. So everything is ready except that list of books. Once we have the list of books, each and every one of the books will be bind to a new text cell. And for each of the books, their name will be set to the text of the text cell and the author will be set to the detail of the text cell. So let's go ahead and get that list of books. Let's open mainpage.xaml.cs and we will have to override one method that will be executed every time the main page is displayed again. This means that if we navigate back to the main page from the new book page, this method should be executed. Why is that? Well, let's picture the scenario where one new book is added from the new book page. If we had only called one time the method that retrieves the data from the database, that new book that was added won't be displayed. Let's say that we only get the data the first time the main page opens. Let's say that there were 3 elements. Let's say that we navigate to add a 4th element. But when we navigate back, we won't be reading from the database again, so only 3 elements will be listed. If we override a method that is called onAppearing, we will be able to execute this every single time the main page is appearing, both the first time and the next times every time we navigate back from the new book page. So we can actually read from the database again. So how do we read from the database? Let's do this on the onAppearing method. And we will have to use a using statement again, where we are going to be creating a new SQLite connection, which is going to be equal to a new SQLite connection that receives the database path from the app class. And inside of the context of this using statement, we have the connection. We also have to make sure that we create the table, because the first time there will be no table to read. So let's make sure that we create it at the beginning. It's going to be a table of type book. And so now that we are entirely certain that there is a table of type book, we can read from it. So how do we read from it? We're going to define a new variable that is going to be books, and that is going to be equal to con.table, and we have to specify which table we want to get. In this case, let's get the book table. And by default, this is only going to return kind of like a list, but that is not ready to be listed into the list view. We first have to transform it into a list through the toList method that is possible to use because we have this using system.link namespace referenced. So now books is a list of books. Notice right here on the screen, when we hover the mouse over the name of the variable, we can see its type, which is list of books. And now all we have to do is get our books list view, and set its item source to be books. So now the list view will have its source, will have its binding, will have a list of books. Each one of those books will be assigned to the text cell, will be bound to a text cell. And now each one of those books will get its name value and assign it to the text property of the text cell, and its author value and assign it to the detail property of the text cell. Just like this. So let's go ahead and run this on the simulator again to test out how this works. Notice that as soon as I navigate to the application, there is already one element, the one that I have added before. It wasn't listed, but it was inside of the database. And because this database persists, it will still be there the next time the application is open. And so we can see that there is already one book in here. And if I were to add a new book, let's say the achievement habit by Bernard Roth, and save this, we can see that it was successfully inserted. And if we navigate back, we can see it immediately listed because we are using the onAppearing method, which is executed every time we navigate to this screen. And there you have it. This is how you add and read from a SQLite database and list all the elements inside of a list view using data binding.